The universe is full of extremes, but few objects inspire as much awe and fear as black holes and neutron stars. One can swallow entire stars and bend time itself. The other squeezes more mass than the sun into a sphere the size of a city and spins faster than any object nature has ever created. If these two cosmic titans were placed in a head-to-head showdown, which one would truly dominate? To answer that question, we need to go beyond hype and science fiction. This is a battle of physics where gravity, density, origin, reach, and strange behavior decide the outcome. By the end, you may realize that crowning a single winner isn't as simple as it sounds. Gravity, the ultimate force. Gravity is where black holes earn their terrifying reputation. At the heart of every black hole lies an event horizon, the boundary beyond which nothing can return. Cross it, and escape becomes impossible, even for light. This is not just strong gravity, it is gravity pushed to its absolute theoretical limit. Black holes distort space and time so severely that the universe around them behaves like a stretched rubber sheet with a massive weight dropped in the center. Objects that wander too close don't simply fall in. They are pulled apart by tidal forces and dragged into a fate from which there is no recovery. In extreme cases, stars can be torn apart in a matter of hours, their material spiraling inward before vanishing forever. Neutron stars are gravitational monsters too. Despite being only about 20 kilometers across, they contain more mass than our Sun. The gravity at their surface is so intense that standing on one would crush you instantly. A tiny amount of neutron star material would outweigh mountains on Earth. Yet even this incredible gravity has limits. Unlike black holes, neutron stars still allow light and matter to escape. Their gravitational pull is immense, but not absolute. In this category, black holes are unmatched. When gravity has no escape clause, the outcome is clear. Density. Matter pushed to the extreme. If gravity crowns black holes, density belongs to neutron stars. A neutron star forms when matter is compressed beyond anything found elsewhere in the universe. Protons and electrons are forced together, creating a sea of neutrons packed shoulder to shoulder. The result is matter so dense that a teaspoon of it would weigh trillions of kilograms on Earth. To put that into perspective, neutron star material is like squeezing the entire population of a massive city into a grain of sand. If such material somehow appeared on Earth, it would fall straight through the planet, barely noticing the resistance. Surprisingly, black holes lose this round. While the center of a black hole is thought to collapse into an infinitely dense singularity, the object as a whole can be surprisingly low density. Supermassive black holes have event horizons so large that, when averaged over their volume, their density can be less than that of water. It's one of the universe's greatest plot twists. The most feared objects in existence are not necessarily the densest. Origins, born in stellar violence. Despite their differences, black holes and neutron stars share a dramatic origin story. Both are born from the explosive death of massive stars. When a large star exhausts its nuclear fuel, it can no longer support itself against gravity. The core collapses, triggering a supernova, one of the most energetic events ever observed. What remains afterward depends on how massive the star was and how much material it lost during its lifetime. If the remaining core is extremely massive, gravity overwhelms all known forces. The core collapses completely, forming a black hole where conventional physics no longer applies. If the core is slightly lighter, collapse still occurs, but neutron pressure halts it before total destruction. The result is a neutron star, a compact, ultra-dense remnant left spinning rapidly from the conservation of angular momentum. Different outcomes, same violent beginning. In terms of origin, neither object has a clear advantage. They are two possible endings to the same cosmic catastrophe. Reach and destructive influence. Power isn't just about strength, it's also about reach. And here, black holes demonstrate why they shape entire galaxies. When black holes consume matter, they often form accretion disks, swirling rings of superheated gas spiraling inward at incredible speeds. These disks can stretch across enormous distances and emit vast amounts of radiation. Some black holes also launch jets of particles that travel close to the speed of light, blasting energy far beyond their immediate surroundings. Their influence doesn't stop nearby. Supermassive black holes sit at the centers of galaxies, subtly controlling how stars orbit and how galaxies evolve over billions of years. Neutron stars can be violent too, especially when they collide. When two neutron stars merge, they unleash gravitational waves that ripple across the universe and create elements like gold and platinum. These collisions briefly produce conditions hotter than the cores of stars. But neutron stars affect their surroundings on a more local scale. Their destruction is intense but limited. Black holes, by contrast, influence space across vast regions and over immense timescales, where neutron stars get weird. This is where neutron stars truly shine. Many neutron stars are pulsars, rapidly rotating objects that emit beams of radiation from their magnetic poles. As they spin, these beams sweep across space like lighthouse beams, creating pulses so regular that they rival atomic clocks in precision. Some pulsars spin hundreds of times per second, making them the fastest spinning known objects in the universe. Then there are magnetars, neutron stars with magnetic fields so strong they can distort atomic structures. A magnetar passing close to Earth wouldn't need to touch us to cause damage. It could disrupt electronics and alter chemistry from a distance. Neutron stars are also cosmic laboratories. Their extreme conditions allow scientists to test physics in ways impossible on Earth, from nuclear matter behavior to space-time effects. Black holes are strange too, warping time and space in dramatic ways. But in day-to-day cosmic behavior, they are often quiet, patiently existing, bending reality without flashing signals or ticking like clocks. When it comes to sheer weirdness and observable extremes, neutron stars take the prize. The final scorecard. The final scorecard shows just how evenly matched these cosmic titans really are. Black holes dominate when it comes to raw gravitational power and long-range influence, bending space-time itself and shaping entire galaxies, while neutron stars claim victory in density and strange behavior, packing unimaginable mass into city-sized spheres and exhibiting phenomena like pulsars and magnetars that push physics to its limits. Their origins end in a tie since both are born from the violent deaths of massive stars, making them two different outcomes of the same stellar catastrophe. In the end, the balance reveals something deeper than a winner or loser. The universe does not elevate one extreme above all others, but instead explores every possible limit of matter, gravity, and energy at once, creating multiple kinds of cosmic supremacy rather than a single champion. Why there is no true winner. Trying to crown one object as the ultimate cosmic champion misses a deeper truth. Black holes and neutron stars are not rivals. They are complementary expressions of nature's limits. Black holes represent gravity unleashed, where space and time themselves surrender. Neutron stars represent matter pushed to its breaking point, where the structure of atoms collapses into something entirely new. Both remind us how fragile normal reality is, and how narrow the conditions are that allow stars, planets, and life to exist at all. The universe didn't choose one extreme. It created both. If you enjoyed this deep dive into the universe's most extreme objects and want more mind-bending science explained in a simple, exciting way, make sure to like and subscribe, because the cosmos is full of incredible battles and mysteries we're just getting started exploring.